We're studying A-level mathematics, statistics 1, and we're starting permutations and combinations 1. In this class, we'll be looking at what is permutation, what is combination, what types of questions you may get in the exam. There's several types of questions. There are several question types which we need to work on one by one. Okay, 1 second. I'll give you the basic formula first, all right? Summary of you have the first thing, which is combination or permutation. Let's do permutation. So permutation, which is usually NPR. Okay. What is NPR? We have, before we do any of this, let's understand something quite basic. N factorial, okay, is 0 times 1 times 2 times 3 times so forth until n. Okay. So, for example, if I have 7 factorial, what would that be?
Um, 5,440, which is 1 times. So wouldn't
Yeah,
0 times anything be 0?
no, there's no 0. Sorry,
Oh
there
my
is
God.
no 0. Yes, obviously. That would be catastrophic. Okay, so no 0, because then every factorial would become 0.
Yeah.
But yes, we start from 1, okay, and until n. Right? Now, there are many ways of writing this. Some people write P and NR or NPR, NPR. Which one do you do in school?
The middle one.
Yes, that's what we should be doing in Cambridge syllabus, right? In A levels, so this is what we do. But if you see something else, don't panic. It's the same thing.
So,
Okay, now NPR basically has a specific formula. The logic behind it is more important to understand than the formula, because the formula would be useless if you don't understand how it works.
yes.
Okay, so n minus r factorial, right? 1 second. Fine. Now, number 2, NCR.
Not this one.
Basically, n factorial over r minus n minus r factorial,
Into our
okay,
factorial.
into r factorial. Okay, that's what I have. Now, if these are the two formulas which I have, this one, and this one. That's literally it. That's your chapter. Let's start with n factorial. That's quite basic, right? We just multiply all the numbers till n, starting from 1.
Thank
Now,
God we have a thing called calculators. I'm really grateful.
calculators. Yes, imagine doing this without a calculator, right?
I would have not chosen math. I would have gone to biology.
Wow. Okay. So big things, we should definitely um, take that into consideration for the future students, right? If anyone says they want biology, then let them know that we do have calculators in math, right? It makes
Yeah.
math bearable. So they can also consider math in A levels. Now, if you look n factorial, look at this n factorial, that's the same thing from above, but n minus r factorial, what is that? Now, this is actually arrangement, okay? Or permutation is nothing but arrangement.
Yeah.
Arrangement. And this is combination.
Like
Now,
it's
the
basically arrangement with rules.
rules, or basically understand here order matters, okay? Everything has rules, but the thing is order matters, okay? Here, order does not matter. Does not matter. Remind me to type it out next time.
Not
Actually, let's just type
tricky
it.
for this one.
Order does not matter. Right?
The questions are tricky for this one.
Yeah, they are tricky. That's the only thing they have going for themselves, right? If they make questions easy, this would be a very easy chapter. There are two formulas. So at least they can make the questions difficult. So there's a point of having this chapter. The thing is, this has a lot of potential, right? And that's why it can get difficult. There's a lot of potential to get difficult questions in this chapter. Now, order does matter, or order does matter, and order does not matter. What is the difference between these? Now, imagine I have, let's say, cat. Or no, let's forget cat. For example,
Need
imagine what
needles. Needles.
needles. Okay, needles. Now, okay, I have this, right? Hmm. What we need to understand first is, um, okay, now we'll get to this question later on because there's repetition here, fine? Let's keep it basic, maybe, basic. Um, a basic way of having it would
Table.
be table, fine. So I'm trying to think of anything but words, okay? Because you'll have lots of words afterwards. It's okay, fine, fine. Or okay, for beginning off, let's just take some apples, okay? Or some
Yeah.
balls. That's more visual. There's a yellow one, and there's a green one, and one more green one. Fine. Now the question would be, you have to place these objects in a specific arrangement. Now, what you need to understand is, uh, each of these also have numbers on them, perhaps. Okay,
Oh, okay.
no numbers for now. Let's just take it like
Oh,
this. Okay, so if I have to place them in any arrangement, I can have yellow. Wait, or let's just put numbers. One, two, and two. Okay, I can place these two.
so you will have three ways of arranging them?
Let's see. So I can put something like this and this in the middle. Okay. Now, that's one way of arranging it, right?
Yeah.
I'm just going to write one, two, two. Okay. So I have one, then I have two, and then I have two. Now one could be in the middle, the one ball, right? It could also be at the
Would
end.
be at the end. So three
Okay.
ways.
Three ways of arranging it. Now, okay, there are three ways of arranging it. What if these balls were different? Right now, what we're taking these to be same. Okay, they're similar.
There'll be six ways.
Six ways. Okay. So if I instead had three there, there would be one, two, three, two, one, three, two, three, one. Now we have to repeat this whole thing again. Okay.
Three,
Would
two,
be
three, one, two, and then one, three, two.
yes. So I would have three,
Two,
one, two, three, one,
two, one, three, two.
one, three, two. Okay, something like this. Now these are all the arrangements which I can do with three balls. Now, um, thing, however, is the thing you need to understand is if order matters, then I need to arrange them, right? And I get these six options. Which is 3p, 3p. Wait, let me get.
No, it'll just be 3 factorial. There's no repeating, right?
There is no repeating.
So it's
Yes.
just 3 factorial.
Okay, 3 factorial. Now, when I do permutation, right,
Yeah,
I can still say 3p3.
3
That's factorial. Okay. What is the meaning of this p? It means from three objects, okay, arrange three objects. Okay? And the formula would be 3 factorial over 3 minus 3 factorial, which would be 3 factorial. Now, another basic rule which you should know, an important one, that 0 factorial is 1, okay?
Yes, sir.
Because there's only one way to place nothing, right? Nothingness. This 0 means nothing, and there's only one way of arranging nothing, as in just having it, okay? So 3p3 is 3 factorial, which is obviously 6. Fine?
Yes.
Okay, so that was for arrangement, which is basically permutation. 3p3. Okay. Now, however, if I had combination, it would be 3c3. Now, 3c3, however, would be how much?
1.
1. So why does it decrease and just become 1? The interesting bit is if you have three numbers, okay, in each of these combinations, all of them are all the numbers are the same, right? In a sense, I have three types of three numbers here. I have the same three numbers here. The only thing changing is that the order is different, right?
Yeah.
Now, since the order does not matter uh, in combination. Order does not matter. So we assume or we consider all of these to be same because they're the same numbers.
Right.
Even if it's like a mixed, it's like a bag. In the bag, we have the same numbers. It doesn't matter if they're here, up, bottom, below, anywhere. They're the same numbers, right? Doesn't matter where we put them. Now, so that would mean there is just a combination of three of three, which is yep, one way, and six ways or six arrangements.
So is it like a unique way of like placing them?
This which one? This is a unique way of placing them, and here you just throw it in the bag, and doesn't matter how they're placed as long as they're in the bag, right? These three
Yes.
numbers are in the bag. In each of these options, it's the same number which is in the bag, right? How they're placed doesn't matter. So there's only one combination in the bag. Or you can think of it like this: you have ice cream, right? Now, if I say mint, mint choco, vanilla or something, right? That's an ice cream. Now, honestly, it doesn't make a difference to me how the ice cream man or the shopkeeper arranges this flavor because it's the same flavor, right?
Yeah.
He can put it one on the top, someday on the bottom, and then the other one on the side. It doesn't matter to me which order they are because the same flavor, right? The same recipe. And there's only one recipe.
Okay.
Now, however, if I instead of saying mint choco vanilla, I had, let's say, some other possibilities. Now, that will happen in the next example. So this is clear, right, so far? Why there's only one recipe or one combination, and six arrangements, six possible ways of placing them. Okay,
All right.
you can think of combination like a recipe. It doesn't matter how you put it, as long as you're putting it in, right? Okay. So this was 3c3, which is 1. So this is some basic stuff you should know. Any like NCN is always 1. NC N minus no NC 1 is also no NC0. How much is NC0? Tell me. Also 1. Okay. Any questions? This is basic stuff which you should know.
Yes.
NC1 is always going to be n, and nc, n minus 1, is also going to be n, because it's symmetrical, okay? The first and the last are same. 0 is the first and n is the last. 1 is actually the second number after 0, right? And n minus 1 is the second last. They're same, okay? Some things to just know and keep in your mind. Now, what if I say I have these three letters, ni, nest, okay? Nest. Now, I only have three box places here. Can you see this? Three spots. I want to find out the total arrangements, which is basically permutation, and total combination. Any questions? This is the question. So,
Yeah.
any doubts in understanding the question?
No.
No. So you know what the question is asking. The first part is asking us to find the permutation. Second part is asking for the combination, as it says. Okay. So if you have arrangement, now I can have n, e, s, or I can have s, e, n, or I can have e, s, n, or any of these, right? Now I'm not going to write this one by one. That's not what we're doing here today. That's archaic. That's an archaic way of solving these questions. The best way is to see how many possible letters are there. How many letters are there? Tell me.
Oh,
4 letters. Okay. Of four, let's say objects. Okay. So I have in the first place I can put 4. Okay. Then so any of these 4 can go in the first place, right? Does that make sense?
yeah.
Now, if I already put one guy, how many people are left to go in the second place?
3.
3. So because in the first one is gone, I put one. There were 4 options then. Now in the second place, there are only 3 options left. Now in the third place, how many options are left from these?
2.
I don't know which 2 are these are. It could be any of them. Depending on if n is gone in the beginning, then only est are left. Then maybe if e is gone, then only st are left in the beginning. It doesn't matter which one it is, but it will always be 2 which are left. Now, the answer would be 4 into 3 into 2, which is 24.
24.
Okay, arrangements. Now, how can that was the logic behind it? In the sense I had any of these, I could put nest in the beginning. Then I could put whatever I chose here. If I chose E, then only NST is left. Then if
Well,
I
that's
chose T,
4 factorial, right?
it's not 4 factorial. It's slightly different actually. Um, it's different in the way that it it is okay. It does look like 4 factorial, but the ending one is not there. Okay, this S is extra. Is that clear? If I chose E, T, and N, this one letter which is left at the end is extra. Clear? So I don't multiply by 1 here. That would not make a difference, but it would make a difference afterwards. Let's see. Now I'm trying to I'm trying to arrange 3 letters from 4 letters. Okay. What if I try to arrange 2 letters from 4 letters? What would
2,
happen?
3, 2.
4 into 3. Okay.
12.
So it would be 12 only. So not 4 factorial, right?
Okay.
Now this would be 4p3 from 4 objects, arrange 3 objects. Okay.
Okay, from 4. Right.
From 4, arrange 2. Or
Okay.
from 4, arrange 1, which would be just 4 and nothing after that. Okay.
Makes sense.
Make sense? So
Yep.
this would be 4 only. Now, what about combination? Now, this is when combination works. Combination would only work if we have either multiple objects. Or no, combination usually works when we need to like pick 5 out of 10 or 5 out of 6. If you're picking all of the 5 out of 5, then there is no combination. It's like you took everything, right?
Yeah.
We need to choose something, have some choice. Don't just take everything, eat everything, Have some self-control. Choose something. So let's try the next question. No, not the next question, but the next part in this question. First part clear for arrangements. And do you understand that if I had to do if I had to choose 4 from 4, it would be 4 P4, right?
Yeah.
Okay, which would still be 24, but it's not the same, right? Okay. Next up, I have combinations. If I'm choosing 3 objects from 4 objects, it's very basic. What I can do is, I can take any of these. Okay, let's see. What combinations can I have? Out of NEST, I can put NST, okay, or I can put NET, or I can put
Yes.
NES, okay. NST and NTS is the same thing
Oh, okay.
because these letters are the same. Arrangement does not matter in combination, right?
All right.
So NST, we're trying to take different things. Like if you take different things, you can try more out, right? Okay. Now I will repeat this. I can take SET. This is unique. Each of these must be unique, okay? Unique combination. That's a unique combination or recipe. Fine. S. I can't write SNT because that's done. NST, SNT is the same thing. So what is left? Nothing is left. SET. That's it. That's it. There's nothing else left. So what this is what you can do. 4 combinations, right? 4 unique combinations from these 4 letters. So if I do 4C1 in this case, it would be 4. Check what is 4C1.
4. But so
4.
why would it be 4C1?
Say it again. Not
Why would
4C1,
it?
sorry. Not 4C1. 4C3.
All right. It's because it's like
Uh,
position,
yeah.
right?
Say it
It's
again.
4. It's the number of positions like available for the letters.
Yes. Basically, from 4, choose 3. Okay.
Yeah.
That's what we're doing,
And
right?
then give them a unique arrangement without repetitions. So
Unique arrangement without repetition. Uh,
yeah,
or unique combination, right? Arrangement doesn't matter here. When you say unique arrangement without repetition, that's like saying no arrangement. Okay,
right. Okay.
just put it in the bag. We don't care how you put it. Just throw it in.
So like
Okay.
ones I practice from, they say that like let's say take like let's say example nest itself.
Start from the
Let's take
beginning. Start from the beginning. Your voice broke off.
like oh okay. Like in the past papers that I have practiced, it's the question is like this. Let's say like we'll take this example itself. Let's say like the first letter and the end letter should be S. The first letter should be S and the end letter should be D. And then in the middle it can be anything else. So then how do you solve it? What are the possible outcomes of
Okay.
arrangement? That's
So
how
we
they
will do
ask in
those
the past.
questions. That's obviously that's how they ask. That's called that's a restriction. Okay, restriction of movement.
Yeah.
That's a type of a question. We'll get there. We have different types of questions. See, we have this. So we have restriction. See,
Oh, okay.
that's literally and repetition, restriction, and then we also have cases, which is written here. Cases. So cases, restriction, repetition. These are 3 types, and I think there is also one more type. Cycle, yes, cyclic. Ah, wait, they're asking not to be included. What? They ask this all the time. Okay,
Questions about objects arranged as if oh, nice.
okay. Even if they're saying they don't ask, okay, what they do is they make it row and column.
Oh,
row column. Okay, usually in seating. These questions are amazing. I have so many questions which I can give you. I will later on for practice. Okay, so far it makes sense, right? What is
Yeah.
combination? What is this? Just it's like a recipe, unique combination and arrangement, unique placement.
Basically like a cooking recipe, isn't it?
Yep, cooking recipe. This is your presentation of the food. Imagine if if you make a burger and you put the meat on top and then the bun and then the other bun and at the end you put the salad or the ketchup. How would that be?
A burger, then the bun, and then the salad. It's basically um a messed up architecture of a burger.
Yeah, it's just a mess. Okay, quite messy. Anyways, continuing with this question, we had that, right? We've done, what have we done so far? We've looked at what is limitation and what is combination. Yes,
Yeah.
quickly, let's just do one more thing. So I have 4C, 2 knife. I only have two places. What is the answer?
4C2. It's 6.
4C1, 4 as well.
4, it's 4.
Okay, so that's that. What about 4C0?
Isn't it 1?
Try.
Okay, I'll try. It's 4 again.
4 again?
Oh, yeah.
No, can't be 4.
4C0, right?
Yeah, 4C0 is 1.
That's what I said. It was 1.
Okay, so it is not 4, it is 1. Okay, because the way of arranging nothing is 1. One combination of nothingness in the bag. You
Yeah.
can go to the store, and if they ask you what you want to take, you can just say, I want one nothing.
1 nothing.
Yeah. Now that's
They'll
over.
they'll
Yeah. What?
probably give you a paper printed nothing and hand it over to you.
Yeah. Please pay the bill of $0. Have a nice day. Don't come again. Okay. So that's over. Now we have some repetition. Let's focus on repetition now. In repetition, we have this bit. Question. Needles, as we
Needle.
said.
Yay.
Okay, needles. Okay. Now in these needles, we have to arrange all the letters, right? Letter questions are amazing. Letter questions can be difficult as well as easy, depending on the person. The practical questions which they ask you are usually more difficult. They can ask you, there is this person who is flying in the air. There
Flying
are
in the air.
there are
Okay.
5 beds he is going to see. Arrange them in 5 specific orders, right?
Why
And
would you
that's
fly?
maybe he's in a airplane or jetpack or something. Okay.
Okay.
Now to find the all total possible arrangements. Now the thing with this is, whenever they ask you to do some combination, they will always ask you to choose. They will ask you to choose.
Is the answer
What's the
120?
120? 1 second. I have to check in a bit. Rabia, can you hear me? Assalamu alaikum. Good evening.
Walaikum assalam. Yeah, I can hear you.
You can join room 1 in
Okay.
the breakout room. All right. 1 second. Yes, and please make sure to record the class.
Yeah, okay. Thank you so much. I'm joining.
Okay, Hamsini, look at this. Total possible arrangements, needles, right? Now, what you do here is you count the letters. How many letters are there?
6.
No,
6.
how
No, no.
many
There's 7. Oh my God. I forgot
counting?
counting now.
You have to go back to nursery to learn
I
counting again.
swear.
Okay, redo life.
Okay, so it's
Start
2
over. Okay, 7
possible.
factorial. Now the issue here is whenever there's repetition, we just divide it. Whoever is
Yeah.
repeating, just divide him. So 1, 2, 3, 3 factorial. So
7.
this E has 3 comes 3 times. So we have to divide by 3 factorial. If there was any other repetition, we would
840.
divide by that as well. How much is it?
840.
840. Is that correct? 7 factorial divided by yes, 840. Okay.
Yay.
Now, if I ask you, okay, the question, if I had to select three, no, yeah, select 3. Now, selection is actually the same as combination, okay?
Yes.
Selection, selection. Yeah, I should have written that there. So, same combination, unique
Unique
selection.
selection.
Yeah. You can't use the same letter to define the same thing, right? Okay. Fine. Now here, if I say the selection of total selections of 3 letters,
What?
how would I solve that? I have to choose 3 letters from these.
Yeah. So 7C3.
7C3.
30.
Not really. I don't think we should do this right now. We'll go back to it, okay, later. But for this one, this is clear, right?
Yeah, that's clear.
This one actually, you can't solve this without cases. Okay?
Without what?
Cases.
Oh, okay.
Case. Without getting a criminal case on you. So stop. Now what we can do is we can try some restriction. Repetition is clear. Right? Let's try one more repetition question. We say we have
I'll try doing this.
abra,
Abracadabra.
abracadabra. Okay. Now find the total
It's a
arrangement.
big word. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11.
I'm sure it's not a single word, is it? You don't care. Just
It's
solve the
not
question.
a single word. Abracadabra is not a single word. Well, whatever. I'm doing this. I don't care. 2, 3,
Yep.
4. I'm gonna prove my concept clearance with this.
Yeah. If you get this wrong,
Oh no.
let me think of the consequences. First do it. And there's a timer as well. You've got to hurry up as well. So 1 minute for this question.
So it's a big number, right?
It's a big number. That's not the type of answers we accept in A levels.
I'm just asking so I don't get a wrong answer.
It should be quite large because we have so many
Yeah,
letters, right?
it's 83160.
Honestly, I don't care about the answer. Show the method.
Oh, okay. It's 11 factorial divided by 5 factorial into 2 factorial into 2 factorial.
Right. That is it. So what we do is if you have
Yeah.
11 letters here, 4, 4, 3, 11 letters. Now which are repeating? So I have one of this.
4 A's, 2 B's, and 2 R's. Or 5.
5 A's.
Sorry.
5 A's. Okay. Now 2 B's, 1 and 2, and then I have 2 R's, 1 and 2.
So how do we get 6 A's? Where is 3?
Where is 3? Okay, yes. Interesting.
That this disease is contagious. I thought I was the only one. I didn't know.
I was thinking, your eyes are not working. Then I make such a mistake.
Who knew
1.
diseases could spread through online conferences?
Wow. Okay, so we have this. Okay, that could be possible in the future, when you have devices in your mind, and
Yeah.
then you can download a virus and spread it. Okay. Finished? That's clear? No questions here?
No.
What was the answer? No need of the answer, actually. You can calculate it or just do it. Find the answer.
83160.
83160. Okay. Large number. Now we have restriction. Well, this
Oh,
is
no.
amazing. This is amazing because we'll be looking at the most classic question, making a team.
That's a classic one.
Office vehicles or something like that. Maybe sports, it's usually office. Okay. Now, if that's what we're doing, that's the theme. I have different people, okay? I don't want to write each of them, but that's how questions work. Let's open a question, actually, so that you can just do it. Something about,
So what about 6 teenagers going on a boat trip?
okay, so rather than writing their names, I'm just going to write down A1, A2, Mr. A, Mr. A1, Mr. A2, or B, C,
So just
D.
name them 1, 2, 3.
No, we have letters, okay?
Okay,
A1, A2, B, C, D, E.
right.
E1, E2. Okay? Now
7.
let's imagine A1 and A2 are married, and E1 and E2 are couples, and B, C, D are just single, lonely. Okay? Now your job is to find out how you can make a team, select a team of 5.
5.
Okay. No restriction.
Oh, then it is.
And E1, E2 are different people. All of these are unique.
Yeah. So is it 21?
So I need the formula actually, not the answer.
7C5.
7C5, yes. Which is 21.
Yeah, 21.
So there are 7 letters or 7 people here, and by selecting 5. It's always best to make these blanks, okay? Don't do it in your mind.
Dashes, yeah, the dashes.
Dashes. Now I am just going to place these people there. However, if I want to select a team, okay, where I have,
At least one couple.
okay, why am I selecting? Actually, we'll go back to selections later. I keep forgetting that we're doing arrangements right now. So arrange a team of 5, no restriction.
Oh, okay, then
Quite easy, the same thing. 7,
P5.
75, right? From 7, arrange 5, which is
2520. That's a big number.
5, 2, 0. Yes, a lot more because, you know, the order
It's,
matters now.
yeah.
Unique placement, not just throwing them in to a van. Right, now, we need to make sure the people, the couples, A1, A2, and E1, E2 sit together. Now, to get this mission accomplished, what you need to do is you need to take into account that these
A
people are actually, they must be in they they sit together,
couple.
okay? So that means A1, let's say A1, A2, okay? Then they are one single block. It's
Yes.
fixed. They sit together, okay? Right now we're not choosing, okay? We're not choosing. There's no selection after.
Oh,
Arranging a team of 5. Ah, interesting. Okay, so this I think you know already. Fine. We'll make it just arrange a team. No 5. Arrange
mhm.
a arrange the team. Okay. Selection later on. Deleting this bit. Find the total arrangements again. So 7P7. Some says
It's
7 says 7. Yeah.
it's 5040.
540.
No, 5,000, 5040.
Okay. 5040.
Yes.
Okay, these people sit together. So A1, A2 are sitting together. E1, E2 are sitting together. Now, where they're sitting doesn't matter, but they're together. That's important. Okay. Now, here anyone could be there, right? This place, this place, this place. Now, instead of actually having 7 people, now we only have
3,
5 people.
5.
1, 2, 4,
Oh,
and 5.
okay.
Okay?
Mhm.
These are like a single entity now. They've combined their souls.
Oh my, that's okay.
Okay? Now, however, there's a possibility of arranging inside as well, which would be 2 factorial.
2 factor.
So, because there are 2 of them, right?
Oh, okay, right.
Or 2p2, which is the same thing. Okay? And then outside, you can arrange them as 1, 2, 3, 4, and 5. So 5 factorial into 2 factorial into 2 factorial. Clear? Any questions?
5.
So it's important to focus on this bit, which is total 5 people right now, 5 objects. Okay,
Right.
so 5 factorial. But these 2 objects can, which is like inside. Now we're looking inside. They can also be arranged into factorial ways, and this can also be arranged into factorial ways. That's why I get more. Okay,
Is it 480?
480. All right, I am not going to check that. Wait, I might as well. How much? 480? Yes. Okay. Now, if I say couples don't sit together,
Oh, so
that's how it is. So they don't sit together. And what would it be? Now, this way, actually, these questions,
BCD will be one thing.
no. Now,
Oh,
in such cases, the most intelligent thing to do is to see, okay, when there was no restriction, then it was 540. So why do I keep saying 540?
minus it?
5040. And they sit together, which is 480. So the times when they're not together are all the other times, right? So basically, together not. That's what we're doing. Together and okay,
And it's
makes sense.
4560.
So 4560. We basically take the total world and all of the times which they were together, we subtract it. So that means we get the values when they're not together. Okay?
Sad.
Yep. So it's kind of high, likelihood that they're not going to be sitting together. Okay. Now, um, that's one way. Another way would be to combine these people and then just take 1, 2, 3, 4, 5, and then
2
3
factorial
factorial.
times 3
No,
factorial.
you would not do 2 factorial. This is how you would do it. A1, A2. You want to find the answer. So you have these as together, right? And these are not okay.
3 factorial.
Another way, actually, this is not how we do it. Actually, we don't combine them. Actually, what we usually do is we take these 7 spaces. Okay, this is how you should actually learn to do it as well. So you can keep B, C, and D. Okay, and these other people they can go in these gaps. Fine.
All right.
They cannot go. They must go in these gaps. That's basically it. Now it's a good, let's say, it's a
So 4,
coincidence that we have enough spaces for all of them. Okay.
yeah, coincidence.
If let's say we'll try a different question, but for now we have 4 spaces, right? So it has to be in the between. It can't be together. So I have to put A1, A2, E1, E2. Okay. Therefore, I would get 3 factorial into 4 factorial. How much
Which
is
is
it?
4, 4.
Is it the same or different?
It's different. It's 144. It can be 144.
144. Okay. Now, actually, the issue is 4 factorial. Why is it 3 factorial? 3 factorial. Yes, yes, yes. Okay. Interesting.
It'd be never mind.
Now, this way. 1 second. I need a calculator. 1 second. How do I put the factorial sign on the calculator?
Shift and x to the power minus 1.
Why don't I have that?
Oh, shit. Everyone has that in their calcs.
Oh, yes, obviously.
It's
I have it.
down the mode and setup one, the shift and
Yes, yes. It was always there. I've been teaching and using it. Okay.
so you were the one who taught me that.
I did? Wow. Okay. It's been a while. Now, I totally did not forget where the factorial sign is. Please ignore. Moving onwards. Now, I do have these 7 things, right?
Yes.
1 second. Try and solve it. See what went wrong in the other method, and I'll tell you in a bit. Okay. So I have 4 factorial. Okay, 7 factorial into 3 factorial into 4 factorial. Tell me how much you get.
It's a very big number, which is not the answer.
That's too big. Yes.
Too big.
Hmm.
It's in
That's
10,000
big.
something.
4 factorial into 3 factorial. That's
Oh, A1 is so it'll be
1
1.
second. This method should not be used to solve this question in one go because the question is not asking for A1, A2, E1, E2, all of these to be not together. Thing is, only A1, A2 should not be together, but A1, E1 can be together, which we were not taking into account. That's why this fill in the blank method is not appropriate. You should find out the total together, okay, together, and find the total combination and subtract total minus together to get not together end. But if you do want to solve this method, you should try the other type of question, A1, A2 together. How do you find this?
Is it
So
6 factorial into 2 factorial?
yeah, so I have 7 boxes blanks. A1, A2 are together.
Yeah.
Now this becomes a single entity or object. And now I have 6 factorial. But these people I can do 2
2 factorial.
factorial as well. So that's the answer. How much is it?
1440.
Okay. Now if I say A1, A2 not together. that question, I it would quite easily be 5040 minus 1440, right? Answer
3600.
100. Now I can have we were doing it opposite, right? Okay, so I can have A1, okay, and A2 not together, and the other people can go in the gaps, right?
Yeah, but they can be at the end of the thing, like one in the front and one at the last also,
Yeah,
right?
yeah, they can be. So let's see, let's see. Okay, let's see. Now I can place these A1, A2, okay, these two people. I have two of them, right? And there's 7 places for these. How can I place them? A1 and A2.
7C2.
7C2 or 7P2?
7P2.
7P2, because or arrangement matters. There's 7 places, and I
40,
want to arrange only two people. Okay, so it would be 7P2,
42.
42. Now, what I'm trying to do is I'm trying to see in the gap anyone can go. So I have what other people are there. How many gaps are there? 1, 2, 3, 4, 5, 5. So 5 factorial. Okay, so this will be 5 factorial.
5040 again.
42 times 5 factorial, how much?
Times 5. 42, right? 5040. Basically the
5, 0,
same thing.
5, 0, 4, 0. Okay. Now, one thing is, now this cannot be 7P2. Okay,
It has
this
to be
cannot be
5.
7. The thing is, we only have how many places it can be in? It can be in, it has to be separate, right? So there must be a gap in the middle always. So it can be in a total of, try this, how much is it?
6P. 3600.
Yeah, see,
Yay.
got the answer.
So instead of taking only factorial for the previous question, we were supposed to take B.
No,
Previous.
this was this one.
Yeah, that was the one.
This is complete mess actually. This is completely wrong. Ignore it. You know what's wrong? It's not wrong. It's a lot of things wrong. We don't use this type of method for this type of question. Number one. Number two, just do better. Okay, think better.
Yes,
We
I shall use my brain power.
Yeah. So don't use this type of method when we have two separate people who are not going to be together. Okay. The thing is, this A2 and A1 can be together. That is a thing. All right. That is a
Yes.
thing. I think it's quite possible to solve this question in that way as well, which we look in the next class. It is
Yes.
actually possible to use it, but this is easy, right? As you can see, the first method was so much easier.
Yes.
But sometimes this is the only way you can pass the exam. You should be prepared. Okay, 6P2. Why are we doing 6P2 here? Because
A B2 is one thing.
cannot occupy adjacent blocks.
Right.
So there's one block less,
Mm-hmm.
one less block.
Block.
Okay, so 6P2 times 5 factorial, that's going to be 3600. That was these were the ways of doing it. Please make sure you remember it. Actually, I've taught this so many times before that there should be n minus 1 always. Okay,
Yes.
n minus 1 p, then the whatever you have. Fine.
Or they cannot be together.
Cannot be together. That's the thing.
Wow, a question took like 35 minutes of our class. Wow.
Yes, because teaching and solving can take time. But I hope you understood something. in these questions, all right? Together, not together. No
Yes.
doubts on this?
Nope.
Easy way and the long way. All right. So you have homework. Your homework is to do passive questions on this topic. Actually, I'll be giving you a worksheet right now. One worksheet.
Just
2
send the
questions.
link, sir, in the WhatsApp. Just send the link.
You have it here. Can you see it? These 3 questions.
Oh yeah.
Okay, so this is the seating arrangement thing. Try doing
So
it.
I think I did this worksheet. Wait. So did you get this from a YouTuber who like, explains the permutation and combinations thing?
Yes. Yes.
Yeah, I think I tried doing this. Yes, I'll do it again. But
Try it again. And do the booklet as well, which I've given you.
yeah, the booklet is supposed to come next week.
This one is from, what was his name? Intuitive.
Yeah, intuitive math something.
Yeah, pretty great. You can also look him up. It's quite useful for revision. No paid
I
promotion.
I saw his videos for the variation and standard deviation ones. Like,
Cool,
sigma
cool, cool.
x squared divided by something.
Cool. So it's quite unorthodox. However, it's a good revision tool. If you know the things already and you
Yeah.
want to revise, then it's useful. You should definitely revise. Okay. So booklet questions, around 10 questions for this. This is going to be next class, and this one is for next class. All right. All right. Then that's all for today. Take care. Goodbye. Have fun.
Thank you, sir.